Hi everyone, I'm Dan. Today I'd like to talk about the cluster sampling with equal size. Then let's have a look of the overview. So what the cluster sampling is? Cluster sampling is divide the whole population into several clusters and choose some of them randomly, and then analyze every unit of these clusters. The keyword of this definition is about the randomly choice, and every unit should be put into the analyze. So here is an example about this. If we want to analyze the teacher quality of the whole city, we can consider the school as a cluster and choose some of them randomly and get the teacher report of every teacher inside these schools and do the analysis based on that. Then let's have a look about the notation. The number of the total clusters in the population is n, capital N, and each cluster contains mi units. The mi stands for I significant cluster, and since the equal size, which we used in this part, so mi is all equal to n. How do we choose the cluster randomly? We use simple random sampling ways to choose them. How many we choose them? We choose small n. So that's it. Then, after we get the number of the cluster n and n, we also say the value of the ith cluster and jth units is Yij. For the population, we use capital, and for the sample, we use small. And the number of the all unit is equal to the m0, which is add all m together, and is equal to the nm. Normally, cluster sampling could be considered as a two-level sampling method, which is first level. If we consider the cluster as a unit, we got SRS. And second level, the sampling size is equal to the number of the population, and then the second level. This is also showed by the notation. So the ith cluster has its own total value, and the population also has this value. The ith cluster's total value is Yi, which is equal to the all unit add together inside of these clusters, and same as the population add all unit inside this population together, we got the total value of the population. The sample size sample part is just small y. The mean part is also have this kind of things. For the ith clusters mean, we can add them together and divide the number of them. And so for the all population, we can also do that. Add them together, divide the number of that, which is also equal to the mean of the ith cluster means. So that's why we use y double bar to stand for the mean of whole population. Sometimes the total value have its own use in the analyze. So the mean of this total value is y bar, which is equal to the my y double bar, and also equal to the mean of the total value of each cluster. Then the variance part. The variance stands for the difference between the units. So for each unit, the S square is the variance for the population, and it is the difference between each unit. And if we consider the unit as cluster SP square, which is variance between the clusters, is stand for the difference between the clusters. And if we consider the cluster as population, we can get the SW square, the variance inside the clusters, which stand for the difference inside of these clusters, which is SW square. And for the variance part, we can for the population part, we use capital, and for the sample part, we use small. For the estimate part, this is the estimate that we could use in next step. So what's the estimate for the mean of the population? We can use the mean of the sample to estimate the mean of the whole population. If we consider the cluster as a unit, it's just as SRS, and also the total population is same. And for the variance of the mean of the sample, that can be estimated as different variance between the clusters, which is consider the cluster as a unit, as we said before, and as SIs, we can get this kind of equation. And also as SIs, we can get this and also change that to the. Then the interclass correlation. The interclass correlation is the correlation degree of unit inside of same clusters, which we use rho to stand for that. And because of this definition, the equation of that could be described as this. And because of this combined is equal to this summary combined. And so we put them all in and get the equation for this estimator. Then we put them all into this equation and get this at finally. The meaning of the different value of the rho we will talk about a little bit later. This design effect. Design effect is something we can use to say if that class sampling is good or not. Is compared with SIS, the design effect is bigger when the method could lead to a bigger error. So the definition of this cause equation like this. And if we remember, we have talked about this before. So put them all into that, and we can get this kind of equation by the transform. Then this part of the equation, which we mentioned before, is equal to this. So you can have this kind of equation, and then which could lead to this by transform and put them all into the equation. And so the design effect is equal to the 1 plus m minus 1, 0. Then we can get this equation. This equation is based on the variance of the mean of the sample. Inside this equation, fnms is also a certain number for the certain population, which means rho is proportional to the SB square. The SB square, if you have remember, is the variance between the clusters. So what's the SB square could be? SB square could be 0, which means no difference between the cluster, and also could be S square, which means the difference inside the cluster is 0. And then put them all in, we can get the rows arranged. So this is stand for the 0. This is stand for the S square, which is it shows that the difference between the different clusters is 0, and this shows the difference inside of the cluster is 0, which is 1, since all the unit inside of the cluster is all the same. And then we put them all in, we can get the design effect is to 0 and m. Then how many clusters we should choose inside of this sample method? The 1 minus alpha confidence interval is this, which is same as the SRS actually. And so put them all in, we can get the sample should be this. And you can see, according to this, it is mostly decided by the SB square. That means the SB square is very important for this kind of sampling method, since if we don't have the difference between the variances could be just SIs. If we don't have the difference inside of these clusters, it also could be the SIs, since we can consider the clusters as one unit. So this SP square, when x becomes the limited value, and it could just change the class sampling method into the SIs. There is some sampling method could also be considered as some special kind of class sampling. For example, systematic sampling could be considered as a special kind of sampling, which is divide the whole population into several clusters and choose one of them to do the analysis. For example, if we use this kind of systematic sampling, we choose the first one and choose every 1. So it's just like we divide them into 1, 2, 3 clusters and choose the first class and to analyze every unit inside of that. There is 2 examples about the cluster sampling. The 2 examples is aim to show what will happen when the difference between the cluster sampling is 0 and when the difference inside of the cluster is 0, which is this. So the 2 examples have same background, which is the building have 10 rooms and each have 4 people inside of that, and we choose 3 of them. Thus, what we want to calculate is also same, the mean and 95% confidence interval and design effect of this sample. Let's see what's going to happen here. For some software problem, I can't write it down to show how this works, so I choose this method to show how it works. So for the main part is add them together and divide the number, which is 3 clusters, 4 people, and then we get to 24.5, which is the mean of the sample, and the variance of the population S square. S square is equal to 3.91, and SP square is 0 since there is no difference between the clusters. So the SP square is 0, and the estimate of the mean of the sample is this equation. In this equation, SP square is 0, and okay, the whole thing comes to 0. And based on this equation here, this part is 0, this part is 0, all is 0, so 0 is come to this value, which is the minimum value of 0, and which is equal to minus 0.3 in the circle. And the design effect. Design effect is based on this equation, and since this part is 0, and then all things come to 0, so design effect is get its minimum value at this time, and which is 0. And since this part is 0, and the whole part is come 0, and so the 90% confidence interval is just a value, not an area. So that's this example 1. Then example 2. About the example 2, the mean of the sample is also same. Add together and divide the number of that, which is 3 cluster and 4 people. And the result of that end up 21.6 in circle. S square inside of in this sample is 89.4, and the SP square is also 89.4, which is equal to S square. Because of the S square is the all difference inside of this sample, There's no difference inside the cluster, so all the difference is caused by the difference between the clusters. And then we add this number value into the estimate of the variance of the mean of the sample. We can get this estimator end up as 0.5215. And then this part is equation. If we put this value inside of that, which is this 2 is equal, and so this part is equal to n, which causes rho is equal to 1, which is the maximum value of the rho. And see, the design effect of that is this, which is caused by, which is mentioned before, and then 1, which is equal to 1 plus m minus 1 rho, which is equal to m, which is maximum value of the design effect. And then put the value of the estimator of the means variance of the mean of the sample inside of this. We can get the 95% confidence interval area is like this, and so it's enough like that. So compare with these two examples. The result part, you can see the design effect is n, which is the maximum value of that, and the design effect is 0, which is the minimum value of that. So the example 1 is much more better than example 2, which is that example 1 is the best result we can get, and example 2 is the worst result we don't want to get. So what's the difference between them two? The difference inside of the example 1 is all inside the cluster. The difference inside of the example 2 is all difference between the clusters. What does this tell us? This tells us that we want the difference placed at the cluster itself, not between the cluster, which means inside clusters should be much more larger than the difference between the clusters, and that will make the design or the result much more better, which is according to the design effect of these two examples. So in conclusion, what can we get from this talk? First, we got the definition of the class sampling, what it is, and the notation about that, the number, the total number, the value, the number, and the total value, and the mean value, and the mean of total value, and the variance of all population in between and inside of cluster, and then the estimator for the mean, for the total value, for the variance, which we will use up there, and then the interclass correlation, which is quite useful to do the design effect part, and then the design effect, which is a signature for the goodness of the sample method, and compare with simple random sampling. And then we got the equation which could being used here, which is contains the rho which we get before. And then based on this equation, we got the connection between the SV square, the rho, and design effect. So we also have the sample size, how to calculate the sample size of what we need, and get some extension, which is other sampling method could be considered as the cluster sampling method, and we have two examples about this to show difference between the difference inside the cluster and difference between the clusters will affect the results and get the most important conclusion, which is we want to maximum the difference inside of the cluster and minimize the difference between the clusters. So that could make us have a better result of the sampling method things. And so that's it. Then is the reference. I choose only one reference of my own textbook, which could let us don't have some misunderstanding of the difference of the different book. So that's the whole talk. Thank you for your attention.